When we talk precipitate reactions, again, this is one of three types of metathesis reactions. It's one of the ways when we talk solution chemistry, we have to pay attention to what we are dealing with. We have to know exactly what we are reacting. Since we're dealing with solution chemistry, we're always dealing with the solutions. We're dealing with stuff that ionizes in a solvent. Now, precipitate reactions are a direct result of solubility differences. Some substances, when we mix them, will combine and come out of solution, and that's what the precipitate is when something pops out of solution. We get something there that wasn't there before. Remember from your previous chemistry classes, precipitate, the formation of precipitate was one of three ways we knew that a chemical reaction had occurred, the other two being a color change and formation of a gas. When we deal with precipitate reactions, it's the direct result of a metathesis or exchange reaction. If we look at something like silver nitrate and potassium chloride, we see something new pop out. We see the solid form, and when the solid forms, that's our precipitate. Notice that the Ag and the K swapped places. Like replaces like. You probably remember hearing that. Now, when we look at this, the main thing to recognize when we deal with metathesis or precipitate reactions, or this particular type of precipitate reaction, is we get selective precipitation of ions. Because we know that some things are more soluble than others, because we know that some things are insoluble in certain conditions, we can use these things to separate out ions, both cations and anions, and this is based on a set of solubility rules. In the lab, you were able to identify many of these solubility rules. So, for example, you were able to figure out that 1A and ammonium ions were, all right here. You were able to figure this out from the lab. Then you look at some of the others. We had chlorides, we figured that out. They're mostly soluble. Bromides. So you look at the halogens. Those are typically soluble. There are exceptions of insolubility. You look at chlorates, sulfates, phosphates, most of our metallic oxides, hydroxides, sulfides, etc. You kind of get an idea. And most of our exceptions run back to number one. Ammonium and 1A are always soluble. So that's where we get a lot of this from. And it is the basis or the application of those rules that is going to allow us to identify the different cations and anions in the lab that you'll be doing, because it is this series of precipitate identification. If we can precipitate something out and see what's left and look at that series of reactions, and it's the series of reactions that will ultimately allow you to identify things. And it all goes back to identifying and understanding what's going on in terms of the reaction and what's going on in terms of the application of these solubility rules.